Now we are going to solve in this video some more problems on projections of lines inclined to both the reference planes. But without watching earlier video, don't watch this video because it will be waste of time. So let's quickly revise the notations we use in solving problems on lines inclined to both the reference planes. TL, that is true length of the line. Theta, that is true inclination of line with HP. Phi, that is true inclination of line with VP. EL, elevation, that is front view length of the line. Alpha, that is inclination of front view of line with XY line or with HP. PL, that is plan length, that is length of top view of the line. Beta is inclination of top view with XY line. And DBEP, that is distance between end projectors. Now if a line is inclined to both the reference planes, then while drawing projections of this line in the given position, in our drawing we draw three pairs of views. A pair of view means front view and top view. So such three pairs of views we draw. So how we label these three pairs of views means the three front views and three top views. It's very standardized labeling. You must remember those. Not only that, length and inclination of each of those six views you must remember. So there are three top views, AB, AB1 and AB2. All three top views pass through top view of point A. And there are three front views, A-B', A-B1', A-B1' and A-B2'. Length and angle of AB. Length is PL, angle is beta. This is inclination of AB with XY line or angle made by AB with XY line. AB1 has length PL, but it is parallel to XY line. In the sense, in your drawing paper, it will be horizontal line. AB1 is horizontal line. AB2 has length, true length and inclination phi. What is phi? You must know. It is true inclination of line with VP. A-B' has length EL, inclination alpha. A-B1' has length, true length, inclination theta. And A-B2' has length EL and it is parallel to XY line. Also you should know that B' and B1' always lie on a horizontal line. B' and B1'. B' and B1' lie on a horizontal line. And B and B2 lie on a horizontal line. Also you must know that from each of these labeled points we draw a horizontal line and a vertical line. Not only that, when you draw a horizontal or a vertical line through a labeled point, which is the other point on that line, you will be always knowing. For example, if you draw vertical line through B', you are sure that on that vertical line point B is, because B and B', front view and top view, must lie on single vertical line. Also you know that through A, if you draw horizontal line, then on that horizontal line point B1 is, because AB1 is always horizontal, parallel to XY line. Also, if you draw horizontal line through B', you are sure that on the horizontal line B1' is, because B' and B1' on a horizontal line. If you draw horizontal line through B2, you are sure that on the same line point B is, because B and B2 lie on a horizontal line. If you draw vertical line through B2, then vertical line means projector of B2. If you draw vertical line through B2, then on that line it must be B2', this point. So it's simple. Read the problem. Line PQ is 100 mm long. Now while reading problem immediately, you write with thin pencil, you write immediately. With faint pencil, you write the data here. Use notations. So true length is 100 mm. Line is inclined to HP by 45 degrees. Remember, clear statement, it is no possibility of confusion. It is a line inclined to HP, not top view of the line, not front view of the line. It is line inclined to HP by 45 degrees, means it is true inclination with HP. Theta is 45 degrees. Line is inclined to VP by 30 degrees. It is true inclination with VP. Its end P is 15 millimeter from HP. It's not mentioned whether it is above HP or below HP. Okay, so we'll read it further. 20 millimeter from VP. It's not mentioned whether it is in front of VP or behind VP. No problem, we'll read further. Draw projections of the line if it is in the third quadrant. Okay, now we are sure that line is in third quadrant. That means all points on the line are in third quadrant. It means this point P given, it is also in the third quadrant, in the sense top view above and front view below. So here it is XY line, here it is projector of point P. What is distance of point P from HP? 15 millimeter, and front view gives distance from HP. So measure 15 millimeters below XY line, because we know that point P is in the third quadrant, so top view above and front view below. So measure 15 millimeter, this is distance from HP, that means it is front view of point P. And 20 millimeter, we have measured it behind XY line, because top view is above and top view gives distance from VP. Okay, this is what we have studied in projections of points. So my suggestion is, without watching earlier videos, you should not watch this video. On engineering drawing, all the videos you should watch in proper order. Draw projections of the line if it is in the third quadrant. So it's not just P but the other end. In fact, entire line is in the third quadrant, means top view PQ, line is PQ. So top view PQ, labeled with small letters of course. PQ is above XY line and P dash Q dash is below XY line. That means the other end, its top view is above XY line and front view is below XY line. Now I have a habit. If I don't know exact position of point Q or any point, then I make a circle around that to remind me that this point is yet to be located. Okay, but at least we know that Q is above XY line and Q dash is below XY line. So this is how we have mentioned here the information in the problem. Have you noticed that there are 5 measurable details? 100 millimeters, that is true length, inclination 45 degrees, inclination 30 degrees, and position of point P 20 and 15. Now what about this 5 measurable details? Remember, you will be always knowing at least 5 measurable details in a problem on projections of lines inclined to both the reference planes. If there are no 5 measurable details, 5 or more measurable details, then it means there is no enough information. Remember this, that is insufficient data case. So minimum 5 measurable details will be given to you when a line is inclined to both the reference planes. Very important to remember. So we'll proceed. We should start with XY line. So draw XY line, label it. Then draw projector of reference point. What do you mean by reference point? A point on the line whose position from HP and VP given, and that point is point P, because we know its distance from HP and VP. So let's measure these distances now to the scale to locate point P and P dash. Here it is front view of point P, 15 millimeters, and 20 millimeters above XY line, top view above, because point is in the third quadrant. Point P is in the third quadrant. So this is how we have drawn projections of the reference point. So this is the procedure. Draw XY line, draw projector of the reference point, mark front view and top view of the reference point. Then through all labeled point there must be horizontal vertical lines. So draw horizontal line through P dash and horizontal line through P. So this is how we start solving problems. Then what our logic is, listen. Finally, there will be 6 views in your drawing. Which 6 views? PQ, PQ1, PQ2, P dash Q dash, P dash Q1 dash and P dash Q2 dash. And what are the lengths and angles made by these views with XY line? You know it. PQ has length PL, inclination beta. PQ1 has length PL but it is horizontal, and top view with suffix 2 is true length and it has true inclination. And since top view gives inclination with VP, we have used notation phi here. P dash Q dash is front view of the line PQ. It has length EL, angle alpha, front view length, front view angle. P dash Q1 dash is true length and true inclination, because dash means a front view. Front view gives details with HP. So this is true inclination with HP. And P dash Q2 dash EL and parallel to XY line. EL is horizontal view. If you draw this table 100 times on a paper, is of no use. If you solve problem by consciously using this information, automatically you will able to remember this information. So initially, keep this information always in front of you when you start solving problem. So as I told you earlier, that on each horizontal and vertical line there will be 2 points. So this vertical line in our drawing paper, there are 2 points, P and P dash. Now through P I have drawn a horizontal line, which is the other point on this line, and through P dash I have drawn a horizontal line, which is the other point on this line. You will be always knowing that. P dash, which other point on this line? Check here. P dash Q2 dash is horizontal, parallel to XY line. Means Q2 dash is on this line. And through P horizontal line, which other point on this line? PQ1 is horizontal. So on this line, point Q1 is. Now what logic we use? Try to understand. This is what you are going to do always in all the problems. After marking the reference point, remember, there are 3 top views through point P and there will be 3 front views through point P dash. Out of these 3 top views and 3 front views, in the sense, out of these 6 views, the views which you will able to draw directly by measurements using the data, draw those views. So this is data. Out of the 6 views, which view you will able to draw? Let's check it. TL and phi, true length and phi, you know, that means you can draw PQ2 directly by measurements. Also, true length and theta, watch here, true length and theta given, that means P dash Q1 dash also you will able to draw directly by measurement. So let's do that. As I have already told you, when you draw a horizontal line through a labeled point, you will be always knowing which is the other point on this line. So on horizontal line through P dash, there is Q2 dash, and on horizontal line through P, there is Q1. I have made a circle. As I told you, I have developed this habit. This circle suggests me that confirmed position of point Q1 is unknown, but at least we know that on this line somewhere point Q1 is. So such a rough labeling helps you to solve problems quickly without any confusion. Okay, now through point P dash, I am going to draw P dash Q1 dash because I know true length and I know theta. What is theta? 45 degrees. So I measured 45 degrees. So this is true length. Don't make this line dark. You know that only PQ and P dash Q dash, these 2 lines you are going to draw dark. This line is P dash Q1 dash. Prompt labeling is very important. If you don't label the points immediately, then you will get totally confused after some time during the construction. Okay, so we have drawn P dash Q1 dash. That is what I told you, that since true length and theta are given directly by measurement, we have drawn this line. Similarly, we will draw PQ2. So here it is point P, and therefore at point P you measure that angle phi. PQ2 makes angle phi. So at point P, measure angle phi. What is that angle phi in this problem? 30 degrees. And at that angle you draw true length 100 millimeter. Which view you have drawn here? PQ2. So label it immediately. So this is very important to understand that out of 6 views, the views which you will able to draw using data you draw it immediately. And in this process, you will find that all 5 measurements will appear on the paper. So first step, what we say first step in solving problems on projections of lines is using 6 views logic. Bring all measurements in your drawing. After bringing all these measurements on paper, procedure is draw horizontal vertical lines through all labeled points. When you are sure that there are horizontal vertical lines through all labeled points, use compass to rotate EL or PL. When you use compass, you get one more point. So through that new point also you should draw horizontal and vertical lines. If you wish to use compass second time, then also without having horizontal vertical lines through all labeled points, don't use compass. Okay, so you will understand it better while solving problems. So through Q2, now horizontal line. Which other point on this line? Q. Q and Q2 lie on a horizontal line. I made circle because right now I don't know position of point Q. Then through Q2 vertical line. Which other point on this line? Q2 dash. Is there any line for Q2 dash on the paper? Any other line for Q2 dash? Yes. So this is how we have located Q2 dash. So since correct position of Q2 dash is now known, remove that rough label. What is the length P dash Q2 dash? EL. Now through Q1 dash, draw horizontal and vertical line. But when you draw horizontal line through Q1 dash, you are sure that on the same line point Q dash is. Through Q1 dash, draw vertical line. Which other point on that vertical line? Q1, front view and top view. So Q1, is there any line for Q1 in our diagram? Yes, this is the line on which Q1 is. So draw vertical line through Q1 dash. On this line Q1 is, and also Q1 is on this line. So that means now we are sure where is that point Q1. What is length PQ1? PL. Once you get the correct location of Q1, that rough labeling I have erased. So PQ1 is PL. P dash Q2 dash is EL. Now, be sure that there are horizontal vertical lines through all labeled points. So yes, through P there are horizontal vertical lines, through Q2 there are horizontal vertical lines, through Q1 there are horizontal vertical lines, through Q2 dash there are horizontal vertical lines. So what is the procedure? Remember, when there are horizontal vertical lines through all labeled points, now you should use compass to rotate EL or PL. Okay, so let's rotate PL. Rotate PL, what does that mean? Listen, this horizontal top view PQ1 has length PL. 3 top views, you know, PQ, PQ1 and PQ2. That PQ has same length PL. PQ1 is through P. Similarly, PQ, this line is also through P. So we'll rotate PQ1. When you rotate PL, you should rotate it through the reference point. About the reference point, it is P. So P as a center and PQ1 as a radius. You draw an arc, but in anti-clockwise direction or clockwise direction, you should rotate in anti-clockwise direction, because by rotating PQ1, you should get PQ. So this is how we have located a point Q. Now once you get that point Q, remove that rough label. Now my suggestion is, even if nothing wrong in that, my suggestion is don't rotate EL. It is better to have a standardized procedure. When you use compass, you get a new point. For example, here you got point Q. Now, unless there are horizontal vertical lines through the newly marked point, don't use compass. So when you use compass, use it once, get a new point, draw horizontal vertical lines through that a new point, And if required, use the compass again. Through Q, draw vertical line. Through Q, there is a vertical line on which Q dash is, and there is already a horizontal line on which Q dash is. So this point is Q dash. Label it immediately. Erase that rough label. And then make PQ thick or dark line, and P dash Q dash a dark line. And we have completed the drawing. It's that simple. PQ is top view of this line PQ in the given position, and P dash Q dash is front view. Draw projections of line PQ means draw top view and front view of the line. In your drawing, only these two lines must be dark, PQ and P dash Q dash. Now, is your drawing ready? How will you come to know? To check always, that's better. Through P, there must be three top views, PQ, PQ2, PQ1. You can identify views from labels. Through P dash, there are three front views, P dash Q2 dash, P dash Q1 dash, P dash Q dash. Q and Q2 on a horizontal line, Q dash and Q1 dash on a horizontal line. If they are not, that means you have lost the marks. If not, that means your drawing is wrong. So Q dash and Q1 dash must be on a horizontal line. Also check, two views of a point lie on the same projector, P and P dash, on a vertical line, Q and Q dash on the single projector, Q1 and Q1 dash on a single projector, Q2 and Q2 dash on a single projector. Also, one very important thing you should understand in this problem, we measured 45 degrees downwards. That is because it's clearly mentioned that line is in the third quadrant. That means point Q, the other end, is also in the third quadrant. So top view above, front view below. So we have measured top view angle upwards and front view angle downwards. Third quadrant, top view above, front view below. So angles also in that manner we have measured. Top view angle I have measured upwards and front view angle 45 degrees I have measured downwards. Okay, so this is correct drawing. After completing drawing, you should insert dimensions. So 20, 15, 30 degrees, 45 degrees. As I told you, these 5 measurements given in the question, you should insert in the diagram. And true length we prefer writing outside the diagram. So write true length. So finally, this is how your drawing will appear on the paper. Read this problem. Line RS 100 millimeters long. So true length 100 millimeter. It is inclined to HP by 45 degrees. So theta is 45 degrees. Inclined to VP by 30 degrees. So phi is 30 degrees. Its end R is 15 millimeter above HP and 20 millimeters behind VP. So R is the reference point. It is 15 millimeter above HP. R dash, front view gives distance from HP, and 20 millimeters behind VP. So behind XY line you should measure 20 millimeters. So 20 millimeters behind XY line, R. So you have realized that point R is in second quadrant. Okay. Draw projections of the line if it is in the second quadrant. What do you mean by that? The other end S is also in second quadrant. So S and S dash both are above XY line. So what that have suggested you that both these angles to be measured upwards. Okay, so let's proceed. Draw XY line. Draw projector of point R. Mark point R. This is R dash, 15 millimeters above HP and 20 millimeters behind VP. This is R. Now through R and R dash, draw horizontal lines. Okay. Now you should know that RS, RS1, RS2, R dash, S dash, R dash, S1 dash, R dash, S2 dash. These are the 6 views you are going to draw. RS has length PL and beta. RS1 has length PL and it is horizontal, and RS2, remember top view with suffix 2 has true length and true inclination. So in general, remember beta and phi top view angles. Beta is actual top view angle and phi is true length top view angle. R dash S dash has length EL and alpha. R dash S1 dash front view with suffix 1 is true length. So true length and shows true inclination. And R dash S2 dash has length EL and it is parallel to XY line. Have you noticed there are two ELs? Both ELs, this EL passing through R dash and this EL passing through R dash. That is why we say that rotate EL. There are two PLs, watch here, both PLs are passing through R. That is why we say that rotate PL. But remember TL is RS2 and TL here is R dash S1 dash. There are also two true lengths in your drawing. But remember, we never rotate true length because watch here, these two true lengths have no common point. So never rotate true length, remember. Now what is the procedure? This is how you should start. XY line, projector of reference point, mark reference point. Through reference point, draw horizontal lines. When you draw horizontal line through a labeled point, you will be always knowing which is the other point on that line. Remember, through R dash horizontal line. Which point on this line? S2 dash. Through R a horizontal line. Which other point on this line? S1. Check here. RS1 is horizontal always. So this is how you try to print on your brain. That's very important. Okay. Now check using data out of these 6 views which view you can draw. So true length and phi given, that means we can draw RS2. True length and theta given, that means we can draw R dash S1 dash. Okay, so we'll draw these two views. And both angles phi and theta you should measure upwards because the other end is in the second quadrant. Had it been given point S in fourth quadrant, we would have measured both these angles downwards. Had it been given point S in third quadrant, we would have measured top view angle upwards and front view angle downwards. And had it been given S in first quadrant, then we would have measured this front view angle upwards and top view angle downwards. So it's that simple. So you should not get confused that on which side of the reference line this angle to be measured. Okay. So R dash S2 dash is always horizontal. So this is the line on which S2 dash. This rough label will help you. When you will mark S2 dash, you will not get confused. Otherwise, there will be many horizontal lines on the drawing paper. So through R there is horizontal line. Which other point on this line? S1. So check here. At point R dash, measure 45 degrees because theta is 45 degrees. R dash, S1 dash is 45 degrees. So at point R dash, you measure that 45 degrees with horizontal. And R dash S1 dash is 100 millimeter long. Label immediately it as S1 dash. Also you can draw RS2. RS2 you should draw through R. So at point R you measure that angle phi. RS2 angle is phi. How much is phi here? 30 degrees. So at point R you measure 30 degrees and draw that line RS2. Okay. So check here. We have brought all 5 measurements on paper. 15, 20, watch here, 15, 20, 30 degrees, 45 degrees, 30 degrees and 45 degrees and true length 100 we have measured for these two lines. So all 5 measurements in your drawing paper. So this is the first thing. Using 6 views logic, out of the 6 views, the views which you will able to draw directly using the data, directly by measurements, draw those views. In the process, remember you always bring all given dimensions on paper. Now measurements are over. Remaining construction is a purely construction work without any measurements. Horizontal, vertical lines and rotation of EL or PL. Let's do that. So through S2 horizontal line, which is the other point on this line? S. S and S2, remember B and B2 on a horizontal line. Here only letter is changed. Similarly, S1 dash and S dash on a horizontal line. Through S2 vertical line, through all labeled points we should draw horizontal vertical line. So through S2 vertical line, which other point on this line? S2 dash. And here is the line for S2 dash. So this is how you are not confused at all. So here you have marked S2 dash. So that rough label S2 dash I have removed. So R dash S2 dash is EL. R dash S2 dash is EL. Okay. Now through S1 dash horizontal line, which other point on this line? S dash. S dash and S1 dash always lie on a horizontal line. Do you remember? I asked you to remember that B dash and B1 dash lie on a horizontal line. Instead of letter B, there is letter S used here. Is there any other point on which S dash is? No. So that is why by drawing horizontal line, you will not get directly S dash. So just label this line in this manner. That will remind you during construction that on this line somewhere S dash is. Okay. Now through S1 dash vertical line. On this vertical line S1 is. So unnecessarily don't draw this projector up to bottom of the drawing paper. We know that vertical line through S1 dash, on the same line it is S1. And there is already one more line on which S1 is, this horizontal line. So here you will get S1. And RS1 is PL. Now check, there are horizontal vertical lines through all labeled points. Now you should use compass to rotate EL or PL. Let's rotate PL. RS1 is PL. Now when you rotate PL, which other view has same length PL? Top view, RS. By rotating top view, you will get top view only. By rotating PL, you will get top view that has length PL, that is RS. This is the horizontal line on which point S is. So draw arc up to that point. So we are not confused. Now if you extend this arc, you will find that this arc also intersects the upper line, but that intersection has no meaning, no significance at all. We know that RS1 is PL and one more view, RS has length PL. So by rotating RS1, you will get RS and S is on this line. Label that point immediately, remove that rough label, and through S you should draw projector for S dash. Now through S, when you draw vertical line, remember simple, through all labeled points you should draw horizontal vertical line. So through S, when you draw vertical line, you know which is the other point on that line. S and S dash, top view and front view on a vertical line. Is there any other line for S dash? Yes. So up to that line you draw that projector, and here it is S dash. Now join RS and R dash S dash. RS is top view and R dash S dash is front view. So this is how we have completed the drawing. It's that simple. The problem was similar to the earlier problem. True length, true inclinations given and a reference point. In fact, all three problems, including that first problem we solved in the last lecture. All three problems, the data was similar. True length, true inclination given and a reference point. Only I have changed the positions of the lines. First, second, third, fourth quadrant, anywhere. In any quadrant that line be, or in any quadrant ends of the line can be. Now insert dimensions. 15, 20, 30 degrees, 45 degrees and true length. All given dimensions you should insert in the diagram. Now read this problem. Line AB, 100 mm long, is inclined to HP by 45 degrees. Now write immediately data, that's always better. So true length 100 mm, inclination with HP is 45 degrees, inclination with VP is 30 degrees. Reference point is end A, 20 mm below HP and 15 mm behind VP. So below HP is 20 mm below HP. So measure below XY line. Remember, below, above, in front, behind, use these words with reference to XY line in your drawing. So 20 mm below HP means 20 mm below XY line. And since this is distance from HP, it should be front view. Front view gives distance from HP. And 15 millimeter behind VP. So I measured behind XY line, 15 millimeters. Top view gives distance from VP. So this is top view. Draw projections of the line if its end B is in second quadrant. End B is in second quadrant. What do you mean by second quadrant? B and B dash, top view and front view of point B, both must be above XY line, second quadrant. What do you mean by that? Both these angles you should measure now upwards. Okay, so let's proceed. Draw XY line, draw projector of the reference point A, measure carefully and mark A and A dash. Draw horizontal lines through A and A dash. When you draw horizontal line through A, you know that on this line B1 is. When you draw horizontal line through A dash, you should know that on the same line B2 dash is. Okay, now through A dash there are three front views. Actual front view has length EL, angle alpha. True length front view A dash B1 dash, that has true length and true inclination. Now true length and true inclination with HP is given. So we'll draw A dash B1 dash. And A dash B2 dash, three front views. So A dash B dash we couldn't draw because A dash B dash has length EL, inclination alpha. A dash B1 dash we could draw because its length and angle both are given. And A dash B2 dash is horizontal and that has length EL. There are two front views with length EL, A dash B dash and A dash B2 dash. A dash B1 dash, front view with suffix 1 is always true length front view. So slowly, once you remember those 6 views and their length and inclinations, when you watch the data, immediately you will realize that true length front view and true length top view can be drawn. So top view with suffix 2 is true length top view. So through A there are 3 top views. Out of those 3 top views, 2 top views have length PL. AB1 has length PL and actual top view AB has a length PL and angle beta. Now PL and beta are not given in the problem. And what you know is true length and true inclinations. So top view with suffix 2 gives true length true inclination, that is AB2. So we'll draw AB2. That is again 100 millimeters. So this point, prompt labeling is important. Also you must have understood, I am sure, that why would I have measured these both the angles upwards. Point B is in the second quadrant. Okay. Now through label, that's all. Now as good as we have solved the problem. Now few more lines and rotation of EL or PL, you will get the answer. This is how these problems are very simple. What is the procedure after bringing all those dimensions on paper? Through labeled points, horizontal vertical lines. And when we are sure that there are horizontal vertical lines through all labeled points, then rotate EL or PL using compass. So let's do that. Horizontal line through B2. Which other point on this line? B. B and B2 lie on the same projector. Now vertical line through B2. And here you will get B2 dash. A dash B2 dash is EL. Now through B1 dash, horizontal line. Which other point on this line? B dash. And through B1 dash, vertical line. B1 dash is front view. Dash is there. It is front view. So on a vertical line, front view and top view of the same point. So vertical line through B1 dash. So B1 is on that vertical line. And there is already horizontal line for B1. So here you will get B1. AB1 is PL. So here it is PL. So AB1 is PL, A dash B2 dash is EL. Now watch the drawing. There are horizontal vertical lines through all labeled points. So what next? Use compass. Simple. So use compass to rotate either EL or PL. So I am rotating PL, AB1. By rotating PL, which other view you will get? AB, top view. AB1, top view has length PL, AB. And is there any other line for B? Yes. So rotate AB1 to get point B. And through B, draw vertical line for B dash. So I have not drawn this vertical line up to bottom of the page because there is already one line for B dash here, this horizontal line, and vertical line through B and B dash lie on same vertical line. So up to this horizontal line you extend this vertical line so that you get B dash. Once you get that point B dash, erase that rough label. Now join A and B so that you will get top view of line AB, and join A dash and B dash so that you will get front view of line AB. Only these two lines AB and A dash B dash must be dark. So this is your complete drawing. Check whether you have inserted all dimensions. So yes, 15, 20, 30, 45 and true length we prefer writing outside the diagram. So this is how we have completed the drawing. In this video we solved 3 more problems on lines inclined to both the reference planes. But in all these 3 problems there was a similarity, and the similarity is in all the 3 problems true length, true inclinations given and a reference point given. But remember, as I told you, if line is inclined to both the reference planes, there will be always 5 measurements given, a reference point and 3 more details. Reference point in the sense point whose position from HP VP given, and 3 more details. Remember, you will don't expect always true length and true inclinations. You may face PL, EL and TL. You may face TL, alpha and beta, or alpha, theta and PL given. So there are many combinations possible. So in our next lecture, we will solve variety of problems. And in our subsequent lectures, we will solve different types of problems on projections of lines inclined to both the reference planes. We will meet in our next lecture. Thank you.